Feature-driven component patterns allow you to replicate individual components in an assembly. However, instead of defining the layout of the components as linear or circular, you instead select an existing pattern as a reference. For instance, in this assembly, we can position the cap screw using mates, then use a feature-driven pattern to put screws in the remaining holes. The first step is to position the first cap screw. I'll use a smart mate to do this quickly. If you're not familiar with smart mates, simply hold down the Alt key on your keyboard and drag the circular edge where the cylindrical face meets the head of the screw over to a corresponding hole. This automatically adds both the concentric and coincident mates necessary to position the screw. By the way, when the hole pattern was created, there was obviously one hole that was the original. The pattern was then based on this original hole. When positioning the cap screw, it's not necessary for the first instance of the screw to be located on the first instance of the hole. You can put the screw in any hole belonging to the hole pattern. Next, let's launch the feature-driven component pattern using the assembly toolbar. The feature-driven property manager is pretty simple. You select the component you wish to pattern, the pattern you wish to use as a reference, and select any instances you want to skip. In this case, the component to pattern is the cap screw. Keep in mind you can select multiple components to pattern as well as assemblies or even other patterns. The next step is to select the driving feature. To make sure you're making the correct selection here, I recommend selecting the existing pattern from the Feature Manager tree. I'll expand the tree, expand the flange component, and select the circular pattern feature. Now, as soon as I do this, you'll see a preview of the cap screw component in each of the holes. Since I don't want to skip any instances, I'll simply click OK, and the pattern is complete. Let's take this example one step further. If I zoom out, you can see there are several other flanges in this assembly. I'd like to have cap screws on each of them, and I don't want to spend too much time doing this. In the previous lesson, you saw how the flanges themselves were positioned using a circular component pattern. In the Feature Manager tree, you can see the circular pattern listed just above the derived pattern that I just created. Component patterns are time-dependent features. This simply means that the order in which they were created matters. Here, for instance, it would have been nice to include the cap screw pattern in the same circular pattern that was used to create the other flanges. Of course, the problem with this is that the cap screw pattern did not exist when the circular pattern of flanges was created. SOLIDWORKS allows us to work around this problem. All we have to do is rearrange the cap screw pattern so it does exist before the flange pattern. I'll simply drag the driven pattern above the circular pattern. Of course, this by itself doesn't cause the cap screws to be patterned. First, I have to edit the circular pattern. Then add the driven pattern to the components to be patterned field. Now, when I click OK, every hole has a cap screw in it.